Good morning, everyone. I want to thank everybody for coming out this early. There was a bit of confusion. I was talking to some folks in the back of the room. Disaster recovery, this is not a support group for the after party. We're going to be talking about cloud stuff, so if that's what you're here for, you're in the wrong room. So I wanted to do a little bit of a level set in terms of what this talk is. So this is a 300-level talk. We're expecting that you have some prior experience with AWS and that you understand some basic terms. Really, the key focus here is that we're going to be showing a little bit of code, but it's not the primary focus of the talk. We're just going to be going over concepts, but at a higher level than some of the other talks. So I want to start off by saying that folks that work in technology, we're all historians, whether or not you know it. We're always kind of looking back through history, trying to find meaning from past examples of disaster or calamity. We're trying to learn from what folks have done previously that worked well and what has not worked well so that we can not suffer those same unpleasantries. So with that, I want to give a little bit of a historical story or narrative that I think aligns with this. So this is Henry Ronstrand. Henry Ronstrand was the captain of a ship you may have heard of. This is the Carpathia. So he was involved in a very large-scale disaster recovery event that you might have also heard of, which is the recovery of 705 survivors from the sinking of the RMS Titanic. So why am I talking about a boat and a captain and all this in a disaster recovery talk? Because some of the lessons that we learn from other industries are just as applicable to events that occur in IT and in the cloud as well. So let's take that opportunity to learn from where folks have maybe made some mistakes and apply those same lessons learned so that we don't make those mistakes. So to begin, everyone knows the story about how the Titanic sank, right? And we know that the Carpathia comes and it's the rescuer and they're able to safeguard all these people. But there's this hidden story that a lot of folks don't really know about. So this gentleman is Captain Stanley Lord, and he's captain of the SS California. So the California was actually on site when the Titanic starts to go down. So in fact, the operator on the California was communicating with other operators over Morse code. And at the same time, the operator on the Titanic was quickly trying to catch up with sending messages as they approached the northern shores of Canada to try and relay. So because the two were in such close proximity to one another, the operator from the California was sending a message to the operator in the Titanic, and the Titanic operator was so busy, in this case the operator was Jack Phillips, he was so busy that he sends the message back to the Californian saying, shut up, I'm busy. Now, I don't know about you, but if I'm trying to help somebody out, and then they send me a message saying, shut up, I'm busy, okay, all right, I'll leave you alone, dude. And as a result, that's what he did. The operator for the SS California decides, okay, I'm going to sit on the line for 10 more minutes, and then I'm just going to go to bed. So in disaster recovery standpoint, what we've just established is a recovery point. So this is the point where basically we had a chance for a recovery, and now we've skipped over it. Now, the next thing in that sort of classic RTO, RPO discussion is disaster, right? So we all know what that looked like from the standpoint of the Titanic. They hit an iceberg. So now, again, from that RTO, RPO design, this is our gap where we would have had data loss. So that operator on the Titanic sends out this message, and he basically says, SOS, SOS, CQD, CQD, we're sinking fast, passengers are being put into the boats. So this is the last radio transmission that we ever hear from the Titanic. And this is analogous to now our recovery time. So we've sent our message, and now we're just hoping that we're going to come back online and that someone's going to come to our rescue. So what are the lessons that we can learn from this? The first is that failure is not one thing. So it didn't just happen that they hit an iceberg that made this such a disastrous story. It was that the engineers never expected things to happen in the way that they did. We'll never have 3 breaches and across a hull. That just doesn't happen. We have more than enough lifeboats to support what a lifeboat was actually designed to do at that time. Because again, another popular misconception is that, well, you just sit out there forever. That's actually not what they were designed for. They were designed for quickly ferrying people back and forth from a recovery ship. So again, failure is not really one thing. So I want to give you an analogy now of what a rescue operation could look like in modern terms. So this is disaster recovery as an event, and AKA watch this. So you may have heard we operate this store. It's kind of popular. It's called Amazon.com. We sell stuff. I'm told we sell everything. And we also sell this really cool thing here called a Raspberry Pi. There's a really great initiative for Amazon right now for IoT. And I had the great opportunity to work on the IoT team on the launch of the new IoT project. And I wanted to show you a little example of how we could have done disaster recovery in this case. So we've got our Raspberry Pi. Now what happens if we take our Pi and attach, in this case, an MQ7 gas sensor? So what these devices look like in physical terms, if you're on the closer side, is it's a very small board and a very small sensor. So leveraging these two devices, we can use the framework on AWS. In this case, we're using the Python SDK, or Bodo, and we're using the native GPIO pinouts of the Pi board to basically sense, am I getting smoke? Am I getting gas? Am I seeing a fire? Now, we could take all that data and stream it into a Kinesis stream and make our choices on when we want to do a failover based on ingesting and looking at that data from the Kinesis stream. But to make things a little easier for today, I'm going to write that functionality directly into my Lambda script on the actual Raspberry Pi device. The reason I kind of want to point this out is that if you were ever to try to deploy this as a real production piece, I would probably suggest that you don't do this. The issue here is that when you go directly to Lambda, if I want to make a change later on about the sensitivity of the readout from that sensor, I'd have to go out to every single sensor in my network and make this change, so it doesn't really work out well. So here's what it would look like in terms of a trigger of an event. So it detected the gas, we've got our data center failover, and now we can leverage a CloudFormation template to start creating a Route 53 DNS switchover and provisioning of resources. So let me show you what this looks like in the real world. So unfortunately, I was told just before that the state fire marshal frowns very heavily on me setting something on fire on stage. So I would like the folks in the top to note that the time that's on the top of this, which is 3:05 a.m. this morning. I also found that the folks in my hotel don't like me setting things on fire inside the hotel. So here we have basically that same device that I just showed you. I'm printing out for you a display that says I'm getting a sensor read, I'm getting a sensor read, everything looks good. Fire in my room really quickly. This is about as quick as I could do it. Sensor lit off. It's detected an event. That Python faller in the Bodo is kicked off. If I go back to my CloudFormation template, my DR is just initialized. So I'm now actively failing over resources in my environment and starting to provision servers and everything else. So it's a kitsch example, and it's kind of silly, but at the same time, the reason I wanted to show this to you is to help you understand just how far you can automate disaster recovery on AWS. We could have these things in a colo facility. We could have them in your on-premise environment. We could have them in your office. And you could say if there's an earthquake, if there's a fire, these are issues where we know we're going to start to go offline. Don't wait to hit the iceberg. Take that early warning and start to get those resources ready ahead of time. So what did this cost? Just for fun, the biggest cost here was the device itself. It was $52. Everything else was in the pennies range. So this total thing cost out at $52.56. So how can we do this, right? So I want to give you guys some real-world examples of things that you can do in terms of disaster recovery and what some of those cost. Now, it's important that when we have this discussion, we think about what kind of event are we scaling for, right? So is this a small-scale issue? Is this going to affect me personally? Is this sort of a larger, medium-scale issue that's going to impact maybe a municipality, slightly larger blast radius? Or is this an event that's going to have regional effect, right? So something that's going to take a lot of impact to a lot of users, maybe across an entire continent, right? So before we dive into those, I want to do a quick level set on common terminology so we're all kind of playing from the same playbook. So when we talk about disaster recovery and initialization, there are some common terms. The first one is called a pilot light scenario. So in a pilot light scenario, basically what we have are resources. In this case, we see a sort of a representation of a corporate network. We've got our environment that's being staged on the AWS side. And basically, everything's kind of off right now. Those resources aren't up and powered on. The only thing that we've got is our data volume for our database, and we're just streaming data to it, right? So that in the event of when an issue occurs, we can basically just cut over our DNS record, take those instances. They start up in a few minutes, depending on how long or how much of a large configuration you have on those resources. And then that's it, right? So this is good for sort of small-scale workloads. So the next classic example is what's called a warm site or warm failover. So similar topology, right? So we've got that connection, but now we've got those resources that are available. They're there, but they're smaller. Maybe we don't have as many of them. So we just have sort of the bare bones of what we need to do to actually be able to come back online. So that when we have that failover, those resources are there, and then we can use something like auto-scaling to start to add more to the fleet as we start to actually take those loads off the real network. And of course, the other classic example is a hot site, right? So if you're doing this in the real world, right, this is the most expensive example of what you could do to design for disaster recovery outside of a cloud environment, right? So this is a complete one-for-one matchup of everything you have. So I want to, in real time, be able to take my resources and fail over. It's a complete clone. Again, really, really expensive because everything's there, right? So I'm running two of everything. And again, in a sort of physical world, huge cost considerations there as well because you now have to pay for a separate facility, separate data lines from a telco provider. It gets heavy fast. So again, failover, we just, in this case, switch our DNS record. So in the past, I kind of wanted to look back through what some of our messaging has been around disaster recovery. And one key thing that I found that didn't sit well with me, because I represent the public sector, is that we oftentimes in these sort of talk about our great, huge customers, right? So everybody knows that Netflix has super awesome automation, and we're really happy to have them partner with us and share resources in the community. But the truth is, not everybody's at that scale yet, right? So there are folks that are in small startups, state and local government that are just starting to get going with cloud, and they're not ready for all of that, right? What they're looking for is the ability to have resources, and they just want to be able to do basic disaster recovery. So what I'm going to do is take you through a progressively increasing difficulty of use cases. So we're going to start off with something on the really simple side, the 101, right? So this is use case one, de-entry for entry-level users. So this could be as simple as CLI-based backup, right? So I have data that's in my environment. It's a server farm. It's whatever it is. And I just need to get this stuff out. I need to get a backup of it so that if our facility goes dark, I've got a clone of it someplace, right? So here, again, I'm leveraging the AWS CLI, and I'm just representing with AWS S3 Sync, so I'm backing up to a bucket, in this case, my bucket. And the lower example is that I'm basically showing you that we could leverage the sync commands to get a sort of upkeep of the two. So I want to make sure that what I have on site is exactly what I have in the cloud side as well. So what does something like this cost? Or what actually, more to the point, what does it actually look like? So here we've got our user, remote location. He's got that script running maybe on a cron tab job, and it's going to our S3 resource. We can dump that into an S3 bucket. We recently launched the standard IA for S3, so it's our infrequent access, which is super awesome. Everybody knows about Glacier, but everybody also knows that Glacier has amazing cost-saving potential, but if you're actually trying to pull from a disaster recovery, going to that RPO, RTO discussion, how long is that lifeboat going to take to get to you? If you need that lifeboat to be there in the minutes scale, that's not what Glacier was built for. It has a 3 to 5 hour recall time for that first byte to come to you. So the new S3IA may be a great option there for resources that are needed more urgently, but that we can have with a slight delay. So again, from a cost perspective, what I modeled out here was a simple example. So I've got 10 gigs of images maybe from my project. I've got 100 gigs that I'm putting into IA, and then I've got a terabyte that I'm parking into Glacier. And this was a whopping $8.55 a month, right? So really, really cost-effective, really easy way to take your resources, on-prem or in other clouds, and safely back them up to a separate service. So let's step it up a notch. Let's go to looking at large archive needs. So again, working with some of my great public sector customers, especially those in the academic life sciences environment. This is a really common use case that I've heard a lot, right? So I've got a next generation sequencer or some device that's pumping out a fairly significant amount of data. And I'm not ready to go all into this cloud thing yet. We just need to have some place where I can park a whole lot of data, and then maybe have some resources where I can do things if things go totally dark. But really what I'm worried about is a mass of data going to you, and we need to have it kind of constantly going as the instrument produces data. So the first problem that you run into in an example like this is that oftentimes these customers have a huge amount of initial data that they want to push to us. So how do you do that? One way is that awesome new device, if you had a chance to go on the expo floor, Snowball. Really, really cool NAS device that AWS will ship to you that you can load your content onto. It has a Kindle screen, so it'll update its screen for you with a shipping and receiving address. Goes straight to an Amazon facility of the choosing, and then we just take that through the import-export service and dump it into an S3 bucket of your choice, right? So in this case, I have the data going into our sequence data, and then I could pipe it out into, say, a flow cell directory. And then, because I have this huge ingest, I could also do things like set a lifecycle policy and start lifecycling that into Glacier if I decide that, we really just don't look at flow cell data after 6 months. And if we do, it's probably going to be, something that can wait. So another way that we could do this is building on that other example that we had, which was the CLI. Same kind of technique, right? So we could script something in our environment and use that over, connection straight to S3 as well. Let's take it up a little, though. So now let's introduce Storage Gateway. So Storage Gateway is a virtual device that you can run in your environment. It presents itself as an iSCSI mount point. It has 3 different options, but in this case, we'd be selecting the cache mode. The really cool thing that we were really excited to announce this past week was the Storage Gateway can now support up to a petabyte. So what we would do in this case is take that cached volume as an iSCSI target mount point, and then take that data and just start flowing it into the storage gateway. And then again, we can point this to S3. So all cool, we've got data in there, but I didn't do it because I want to get data in there. I need to actually be able to start analyzing this and doing something different with it. So how do I get my data back? So the good news is that the flow is basically the same. I can take those resources. If I needed to, say, take the entire massive data set that I just shipped out to you guys 5 years ago, I need it all back. We can leverage that same snowball technique. We can leverage that same CLI-based technique. We can use those storage gateway cache volumes and bring that data back through that mechanism as well. What does this cost? So this is the only example where I had to put a asterisk or a variable. And the issue here is that the import-export service is $249 per data loading hour. But there is some variability on the size of storage device that you could be shipping to us. So I didn't want to use an example of like a 1 terabyte drive when maybe that's not practical. So slight variability there, but a petabyte on Glacier would be $7,000. So 1 petabyte, not a terabyte, 1 petabyte of data would be $7,000. And if we wanted to park, some active data that's coming from the sequencer right now, say 10 terabytes, that would be, $100 on S3. So the important thing to take away here is that this number is significantly higher than that last number, right? So the last one was $8, and now it's $7,000. Again, I really want to stress that that is a petabyte of data. If you were to go and try and provision a petabyte of resources through a traditional hardware provider, you're looking at a very large 6-digit number often if you were looking for the same durability and availability that you'd be getting with an S3-backed resource. So another use case that I want to share with you, this one I'm really proud to share with you. This is one of our customers. This is an on-site virtualization replication backup technique. I'm not aware that this has been publicly disclosed yet, so you guys get to kind of hear about this first. I also want to give kudos to an essay that is somewhere in the audience here, Jamie Butler, who is from the public sector team that I'm on as well. This was actually Jamie's work working with this customer to come up with this very clever technique for this customer. So this is a large-scale university, and they have a very big VMware environment that they have. And they were really worried about having to set up a cost-effective DR site for their VMware environment. They had looked at some solutions through third parties, but because they're that academic customer, they're budget constrained. So they needed something that just worked, and they needed it to be as cheap as humanly possible. So what Jamie had found was an interesting way to sort of stage this environment. So using the storage gateway in that cached volume, you can present that through that iSCSI mount point and show that to a VMware replication device that's also in that same environment. So that replication instance now sees the storage gateway as a mount point, and we can start to take our VMs and replicate them to the storage gateway. And because the storage gateway in this case is running through the cache mode, this is being dumped into AWS as EBS volumes. So in this case, what the customer told us was that what they were really worried about was a sort of large-scale event. So they had looked at trying to cover a scenario where maybe an airplane came and hit the campus, or I believe in this case, the data center was actually underground. It was below ground in a floodplain area. So these resources for this particular customer were mission critical, and they wanted to be able to bring them back online. But again, cost concerns, right? So cool, you guys have given me an awesome way to do backup. Really appreciate that. Now I need real DR, right? I need to come back up from this type of event. So also, big thanks to Jamie. What he figured out is that because these are EBS-backed volumes, I can take those into our Ubuntu AMI, import that EBS volume, get that VMDK out, use our VM import utility and conversion, and then take that and make an AMI. So now I've got those resources that previously had been stored as VMware images. I've now converted them into AMIs, and I can actually now start taking those resources and provisioning them in AWS and a VPC of their design. So when we talked about this, this hadn't been fully weaponized, and by weaponized what I mean is that there was not a complete automation of this. These are still manual steps at the very end, right? So I'd have to go into the facility, or I'm sorry, to the console and take that volume and do these operations. So leveraging our SDKs, we can take most of these steps, including the provision of the recovery host, through our CloudFormation templates and have that bootstrapped so that when it comes up, it calls up to the storage gateway, takes those resources, and automatically starts converting them over for me and provisioning those AMIs. And then we can set additional constraints into that so that we then take those AMIs and start provisioning additional resources. Now, I want to be honest, there would still be some manual operation here at the very end to fail over their primary DNS because their DNS was owned by them, not leveraging Route 53. So they'd still need to update their records on their side. But the good news was, in this case, this solution came out to be $1,000 a month. For them, this was a huge cost savings. And when they had looked at third-party solutions for this type of scenario, they were much larger orders of scale. I think the number I heard was something like roughly $30,000 a month or something like that for a comparable technique through a commercial provider. So with this, they were able to get the same functionality that they were looking for, but they were able to do it at a very cost-effective scale. So let's take it up a little bit more. Now let's talk about multi-site replication and failover. So Previously, I've been showing you a lot of Route 53 switchover with CloudFormation templates. Cool, but that's not what we do. I've got a VPC that's floating out in AWS someplace, and we don't have a connection to the internet. We're just using a VPN, or in this case, a direct connect to that resource. And I want to be able to have it so that, in the event that a region or there's a fault somewhere in the Amazon system, I want that to go from, say, the West Coast, or in this case, I'm sorry, the East Coast, to maybe the West Coast. So what would it take to do that? So in this case, we can see, again, we've got that direct connect. So I can take those AMIs and I can stream them or copy them to another region. So I take my AMIs and I can do this programmatically, maybe over, again, going to that RTO-RPO discussion of how long can I suffer a difference between one site and another site. So are we really into DevOps? Are we making changes at the minute scale? Or do we really not change our core infrastructure once a day? So we can mirror that same build process with our replication process. So we've got our AMIs. I can also take our EBS volumes, and I can copy those over to another region. And again, we're sort of setting the stage for these resources are being copied over. We're not bringing over everything. We're just bringing over the data elements. So our event happens. The East somehow goes completely offline. So what we would do then is we could leverage a CloudFormation template to look on either an API-controlled alarm through CloudWatch monitoring. If you want, because AWS has such great APIs, if you were using a third-party service or your own external monitoring, you could trigger that CloudFormation template through your own API call, take those resources that we had previously copied up, in this case, that EBS volume. We can take our AMI over, leveraging that CloudFormation template. And because we can describe our entire infrastructure that we previously had on the East Coast through that JSON formatted file, we can get a complete copy of what was in the East Coast in terms of our security groups, our subnetting, our IP ranges, all through that CloudFormation template. We've got our resources have come up online, so we've got multiple availability zones. And then we can finally take our direct connect, plummet back into the East Coast region. And then if we really wanted to go belts and suspenders, we could also protect ourselves by having a secondary VPN failover, so that in the event that a direct connect goes offline, we can fail over to that VPN connection as well. Now, because this is a disaster talk, I want to share a customer example with you and why this is a consideration that you should make. So it's not a secret. In the San Francisco Bay Area, there's been someone that's going around and cutting fiber optic lines throughout the entire Bay Area. The FBI and some of their federal partners are actively looking into who this person is and what they're doing. But I had a customer who was leveraging our Direct Connect, and they had a situation where the fiber that had been cut was the fiber that provided their feed. That's not something that comes from Amazon. This is through a third-party provider like a Level 3 or Verizon or AT&T. But nonetheless, they were still impacted, right? They went offline. But because they had this secondary VPN fallback, they were able to basically take that downtime to the scale of a few minutes when they detected that the link had gone dead, and then bring up that VPN connection at a slower transfer rate, but at least they were operational. So another example that I'm not aware of has been shown before is doing container-based failover. So we're really, really proud of the ECS service. A lot of our advanced users now are moving to Dockerize or containerize their workloads. But I was not aware of any real disaster recovery for what happens when you have on-prem resources that are Dockerized that you want to bring into AWS. Now, because these are containerized workloads, this is a really cool example of how you can do a seamless failover, right? Because I don't really need to worry about what those instances were made up of anymore. It's all in the container. So in this case, what I've got is a fleet of Docker servers. Maybe these are virtual instances, and I've got that storage gateway again. Again, sort of a neat trick here is that I could use that same technique where I take that snapshot. And in this case, I've got that EBS volume that's being copied over. Maybe this is where I've got some of my build area. So it's not necessarily the entire operating system, but it's like a slash partition. So again, we're taking our database, doing a mirrored replication. And now we've got our disaster-based event. So the clicker, there we go. Our event has occurred. And again, what we can do is fully automate this. So I can take my DNS record, in this case through Route 53, do a failover, point it to the ELB, take that ECS cluster, spin it up for the size that we want based on that CloudFormation template, or we can do it manually on the fly. And then when those instances come up, I can bootstrap them to call out to Docker Hub and take those Docker containers directly from our registry and start provisioning them for us. That EBS volume that I had copied out earlier, we can use that too. So we can take that EBS volume that we had and attach it to those instances as they're coming online as well. So if that, again, was maybe a config directory or something that we had stored assets in that we don't want over a parallel file system of our creation or the headache of that, we can take that volume and attach it to one of the nodes, or we can snapshot it and attach it to multiple nodes if we needed to. And then we've got code maybe that we could store into an S3 bucket. Again, using that bootstrap command, we can bring these resources online, call out to that S3 bucket, and we're off into the race. So going back to the prior example where we were looking at the server-side direct connect type failover, this came out to a whopping $628. So the 1 gig direct connect that was shown, VPN fallback, we had some EC2 instances and copy operations. On the Dockerized container instance, and I should point out, I think in the prior example, that was over 30 days. So my assumption was that these resources were going to be running for an entire month. So this wasn't an hour. This was for an entire month this was going to happen. Same thing on the Dockerized example. We've got these resources, and we're going to be running them for 30 days in this case. So moving on to use case 5. So this is one that also I wasn't aware of that we had talked about publicly, so I'm glad to be able to share this one with you. So we talk about servers, we talk about code, we talk about all these resources for disaster recovery, but everybody forgets about the one thing that really is going to impact you. Where are your knowledge workers working, right? So the people that come into the office that produce your code, what happens when you come in on Monday morning and your office looks something like this, right? So it's Sunday, you had a fire. That looks like a disaster to me. So how could we have a DR solution for this? So you may know we have this awesome desktop streaming service called, it is Friday and I'm Workspaces, thank you. Woo! Workspaces. Workspaces is an incredibly powerful desktop streaming application. Leverages the PC over IP protocol, so very fast, very responsive. The user interaction with the resources, near real time if they have a good low latency connection. So in this case, what I'm describing is I have my corporate network. We've got our resources, so I've got corp servers, I've got my AD environment, I've got maybe some MFA, radius, something that's inside that we want to have. Maybe I've got archives, so again, I can take those archives, pump them into S3. I can take my AD environment, and I can replicate it to AWS, to a region. I could have an ADFS connector as a proxy, but what I really want is I want the capability to cut a line, right? So that the whole facility goes dark, so I want a complete replica of my environment. Same thing on the corporate servers. So I want to take those resources, and I want to have a complete replica. So the question around how much and how fast we should be doing this really goes back to, again, how fast you want that lifeboat to come to you when the ship goes down. But if you can sustain minutes to hour scale of difference between the event timing, this is really fairly easy to orchestrate. So our event happens. We came in Monday morning, and the office burned down. And now I need my mobile workers to be able to go back and work in my environment and use those resources. But I don't know, why don't I just give them their laptops, right? Like, they'll just use their laptops, BYOD for right now, and we'll just ride this out until the office gets done. Do you know what's on everybody's laptop right now? Is there like some weird janky malware that could be on there? Kids maybe put some weird app on there that's got some awesome backdoor that's going to siphon all the data off of that device. How do I make sure that those corporate intellectual assets can't be copied off now in a thumb drive? Because before, in our physical environment, we had our desktops tightly locked down. We wouldn't let things go in and out of the office. What am I going to do in that sort of BYOD environment? So this is why this workspaces example is really powerful, because the only thing that is going to the user is the pixels, right? So the PC over IP protocol is moving pixels, right? So we're not actually moving data to those resources. So in this case, I can have my corp user that, again, really excited to talk about the changes here, using a mobile device like Android, iOS, iPad device, Mac, Windows type client, simple client that comes online on any of those devices, and when they spin it up, they can see the desktop that we had provisioned for them because we had part of our AD environment copied over as well as our directory environment. So I can take that initial image that we used maybe in our normal desktop build operation, take that, provision a workspace based on that same type of environment so we can push our same GPOs to it, our same policies to it. And when that user gets that desktop, they'll have the same type of environment that they had when they were working previously. Now, more importantly, again, why not just BYOD this thing? Without sounding crass, not all knowledge workers are really good about things like, it was on my F drive. What are you talking about, your F drive? I don't know what that is. They're talking about some mount that's somewhere on one of the servers that you have in your environment, but you don't know what that F necessarily maps to. And now they're going to be all disgruntled because they can't get that resource. Again, the beauty to this workspaces solution is that it's seamless to them. All they see is the same desktop environment that they had seen previously, including a picture on the background of a happy cat dancing or something. So what would this cost? So again, over 30 days, right? So that's enough time to find temporary housing or temporary office space someplace. This came out to a whopping $2,000. And that was for 25 users. So we had 25 users, 100 gig EDS volume that we were using for our AD controllers. We had half a terabyte of data that we had copied up to S3 in addition to data that we had in our file services. And again, really, really cost-effective here, $2,215. To be able to go out and buy physical hardware, you wouldn't be able to get it this fast, and you would not be able to get it this cheap. And then, maybe at the end you decide that this whole thing worked out really well, and when we get to the new office space, we're not going to buy workstations ever again anyway. Fingers crossed. So this last one I threw in for fun because, I know from the registry, the makeup of the crowd was slightly technical. Where I worked at previously, I worked at a hospital, and I carried a pager, and I was on call for extended periods of time. I have a family. I'm not really super excited about having to carry a pager with me at all times, and this is becoming increasingly important to the millennial generation. So all well and good. You guys have these awesome automation tools, cool. I see it. I read your SOC reports. I believe that you guys are doing what you're saying that you're doing. I just don't feel comfortable with this automation stuff. I want my people in control. That's cool. It's cool, though, at 2 in the morning on Saturday when everybody's gone, right? And now the pager goes off, and I have to go and deal with this. So how can we lessen that burden for them? The mobile console app. So available on all the popular platforms, Android, iOS. This is a complete dashboard of your AWS environment that I could use to spin up servers. I could go and take a CloudFormation template and deactivate it or activate it. I can interact with my services so that at that 2:30 in the morning wake-up call, I don't have to get out of bed, go to the laptop, get my VPN token out, log in, type it again because it's 2 in the morning and I didn't read the code correctly. I can just take my phone out, look at it, yeah, great, okay, over, done, and it's over. So same thing, we're not always going to be at our desk, right? So 2 in the morning is an easy example. What happens at a large, company event or something where everybody's out of the office anyway? We want to be able to let our knowledge workers, have a little bit of freedom, have the capability to not be so tightly tethered down. And this is, again, I threw it in just for fun because I think it resonated with some folks that I had spoken to about pains working as an operator. So some conclusions. What can we take away from everything? So the first thing that's really important to understand, and I should point out before you start getting itchy in your seats, I do have one surprise at the end, so you may want to stay for just a second. And I assure you that this has never been shown before, and hopefully, knock on wood, the lords of the presentation are going to be awesome to me today. Really important to plan for more than just what you expected and what you're hoping to have happen. You need to make sure that you actually plan your environment so that you're actually testing it. So if we go back to that lesson learned of the Titanic, their assumption was, well, we have a short amount of lifeboats, but at this point, lifeboats are really only used to carry people over, and some boat will come and save us, right? Sometimes that doesn't happen, right? So when we do our continuity planning, we need to make sure that we take that into account and really evaluate how much risk we're comfortable with, and then make our design considerations based on that. Again, test. You made a plan. You put it in a book. The book goes into the shelf. Ops teams knows where that book is. The event happens. What are we doing? I don't know. Do you guys want to get the book? Yeah, but I got this phone call right now, like, we got to get this going. Okay, so you're hoping that they're going to go through that pre-flight checklist that you spent 6 months drafting, right? Make sure you test your execution plan, and make sure that part of that testing is that everyone knows what their job is, so that they know that if you're going to use manual tools, they know how to use them properly. And if you're using automated tools, the same is absolutely true, right? Don't assume that because you programmed it this way that it's going to work because I said this equals this. Right, but there's this condition that just changed now, so that's no longer a true statement. So really important that you test that. Knowledge is critical. So again, going back to our example, knowing how to interpret an alarm of an event. So we had our issue, it went offline, and the boat starts to go into the water. We need to share that information with folks in a way that's meaningful to them, so that they can actually take that information and weaponize it. So how easy can we make this? This is a real live console. This is my demo account that I've got, and I'm looking at an empty CloudFormation stack, so everybody believes that this is live. It's not a screen recording. Circle, circle. So how fast and how automated can we make this? Well, we have these cool things. You may have heard of them. It's called Alexa. So Alexa is part of the Echo app. Oh, she's actually listening. Sorry. Down, Alexa. Part of the Echo application. So let's try this. Alexa, activate reInvent. Volume up. Alexa, start reInvent.
Hello, Brad. System load complete. How shall I proceed?
Well, say hi.
Hello, reInvent. I hope you are enjoying Brad's talk so far.
Alexa, reInvent, tell us what your status is.
I wasn't able to understand the question I heard.
Live demo. Alexa, reInvent, tell us what your current status is.
For help with what you can say, take a look at the things to try section in the Alexa app.
All right. Always on the live side. Alexa, ask reInvent, what is your current status?
My current status is operational. However, I wish I could say the same for your lab.
What happened to my lab?
Your IoT sensors detect a fire in the lab. All systems are offline.
Oh, this is so embarrassing. Alexa, tell reInvent to fail over my data center.
Sorry, I can't find the answer to the question.
Alexa, tell reInvent to fail over my data center.
Warning, you are activating the failover mode. Trigger safety removed. Are you ready to proceed?
Make it so.
Complete. Ladies and gentlemen, that is how you fail over like a boss. Hashtag Alexa failover.
So, all joking aside, I know it's a silly example, but what I really wanted to showcase there is just how far you can go to automate this environment. So before the Reddit community goes wild and says, whoa, yeah, you would do that, and someone would come into your office and just be like, hey, Alexa, fail over the data center. Notice that I put a trigger in there that actually had a safety mechanism so that by default, when the instance came online, it actually would have told us that there's a safety on the lock. And then we could have configured that with like a keyword that was under glass or MFA or something else. But again, I know it's a silly example, but I really wanted to showcase that off as something that would make it really easy to understand just how easy we can make this. So the Echo and Alexa fail over my data center. Cool. So that's all I have for you guys. I hope this was great. Alexa, stop.